You start by finding the derivative of this function using the definition. Well, let's spell out what the definition of the derivative is first. F prime of x equals the limit as h approaches 0 applied to the difference quotient. And although this is an optional piece to show, it's a nice piece to have so you can see how you put everything together. Next step, we are carrying the limit through until basically we've done all the algebra here, right? Once we've done all the algebra, we simplify, then we can apply that limit. So let's start setting up the basis here for that algebra. Let's start with f of x plus h. F of x plus h involves going back to the original function, locating my x's, replacing those x's with x plus h. So when I do that here with this function, I've got 3 times x plus h as a quantity squared minus 5 times x plus h. The difference quotient continues, and I talked about this the last time, where we could kind of highlight our steps, right? If you throw some brackets on here, that highlights the f of x plus h part just to keep everything clear. With the difference quotient, it continues by subtracting whatever f of x is. Of course, f of x is the original function. So original function, 3x squared minus 5x. I insert in, and I use brackets again to show the substitution, but the brackets here have some significance because I am going to subtract. I'll have to carry that negative through. So this is all over h. There's the initial setup. And now it's time to do basically a whole lot of multiplying in this next step. So still simplifying, still applying my limit. As we simplify, we've got this binomial we probably want to expand first, this x plus h squared. So I mentioned this last time too. If you need to, work it out off to the side. Foil things out. After I foil things out, I can understand that that's going to go in this position here. A 3 is being multiplied to that. So 3 gets distributed through. I get 3x squared plus 6xh plus 3h squared. Moving on, we've got a negative 5 here to distribute through. Negative 5x minus 5h. I've got a negative here to distribute through to the 3x squared minus 5x, so it's minus 3x squared plus 5x. And that is all over h. So all the multiplying, that piece is complete. Now if you collect like terms, notice what subtracts out. 3x squared subtract out. The 5x's subtract out. And we know we're doing this correctly if we only have h terms remaining. Because the idea is I'm going to take this h down here and divide into those terms. So one more step here is simplifying. Still applying my limit because I haven't actually done the calculus part yet. So as we simplify, dividing this h through, 6xh divided by h, 6x. 3h squared divided by h, got plus 3h. And you got a minus 5 left for that minus 5h divided by h. The difference quotient in the simplification part is now complete. So we add one tiny little calculus step here where we apply the limit. Since h is approaching 0, any h's we see over here, those terms drop out, and we're left with just 6x minus 5 as our derivative. So first part of this problem complete, and really the longest part of this problem complete. But the problem continues. It says, then find f prime of 2. All right, so f prime of 2. We've got a derivative of f prime of x equals 6x minus 5. F prime of 2. I take 2, I plug in. It was 6x minus 5, so it's 6 times 2 minus 5. f prime of 2 is going to be 12 minus 5, or just 7. So it says, then find f prime of 2, which we did, and use it to find the equation of the tangent line to the parabola y equals 3x squared minus 5x at the point 2, 2. So notice the parabola in that equation is the same as the original function, which means if we found the derivative of the original function, as we did, we're going to have a slope, basically a slope formula. And that slope here for my equation of the tangent line is going to be equal to the derivative at the x value at the point. And the point was 2, 2. So you're taking 2 and you're plugging in. Now, obviously we've done that already. There's a reason they had us find f prime of 2 already, because they knew that would lead us to the slope idea. So the slope here is 7 for our equation of the tangent line. Equation of the tangent line we put in point slope form. So in point slope form, we take y minus the y value at the point, which is 2. We set that equal to our slope of 7. And we multiply that to x minus the x value at the point, also 2. So I've got my equation. I've got my f prime of 2, which led me to that equation. And I got my derivative, which led me to the f prime of 2, which led me to the equation.